2, quadratic formula. So part 2 of solving quadratic equations, we're now going to learn about the quadratic formula. So the solutions of a quadratic equation in general form of ax squared plus bx plus c, when a does not equal to 0, it can be solved by using the quadratic formula, which is negative b plus or minus the b squared minus 4ac all over 2a. Must remember this formula if you haven't learned it once before. But before we get to solving by quadratic formula, there is something inside of the quadratic formula called the discriminant. The discriminant determines how many or the type of solutions that you will have. The discriminant is b squared minus 4ac. Now, when the discriminant is positive, that means you'll have 2 real solutions. When the discriminant is negative, that means you will have no real solutions. And when the discriminant is 0, that means you'll have only 1 solution. So, what better way to do it than by example? Okay? So, I have 3x squared plus 6x plus 3 equals to 0. I've already labeled off each of my coefficients. So, a would equal to 3 because it's listed before the x squared. B would equal to 6 because it's in front of this x. And c would equal to 3. So, using my discriminant, b squared minus 4ac, I want to determine first what type or how many types of solutions I will have. So I have 6 squared minus 4 times 3 times 3. Well, 6 squared will give me 36, and 4 times 3 is 12, times another 3 is 36. So 36 minus 36 will give me 0. So according to my directions, I should have only 1 solution. So now we take this valuable information and plug it into our, quadratic formula. So again, the quadratic formula is x equals to negative b plus or minus the square root of b squared, minus 4ac all over 2a. So my b again is positive 6, but the equation started out with a negative. So that would be negative 6 plus or minus. Well, b squared minus 4ac is your discriminant. So if you've already found your discriminant, there is no need for you to do any extra work. So that would be plus the square root of 0 all over 2 times my a would be listed as 3. So the square root of 0 is just itself. So there's no need for us to have this plus or minus in the front. So this now gives me negative 6 over 6. Well, negative 6 over 6 is just negative 1. So I have only 1 solution. Okay? Next example. I have 2x squared minus 4x equals to 3. Now, is it in standard form? Again, standard form is ax squared plus bx plus c equals to 0. It's not in standard form because the 3 is on the other side of the equal sign. So I must subtract the 3 from both sides first. So this now gives me 2x squared minus 4x minus 3 equals to 0. Now I list all of my valuable information. A equals to 2, B equals to negative 4, and C equals to negative 3. Using the discriminant, I now determine how many solutions I have. So my B is negative 4, so that would be negative 4 squared minus 4 times 2 times negative 3. So 4 squared is going to give me 16. 2 times 4 is 8, and 8 times 3 is 24. But that would be plus 24 because this is negative 4 and a negative 3 multiplied together. So 24 and 16 make a positive, wait for it, 40. So now that my solution is a positive number, now that I know that my discriminant is a positive number, I know that I have 2 real solutions. So using the quadratic formula, I plug in my information. So that would be negative 4 plus or minus the square root of 40, because again, we've already used that information or found that information, divided by 2 times 2. So if I simplify, some things, I can do that as well. So, the square root of 40. Can I simplify the square root of 40? Well, let's break down the square root of 40. 40 is 4 times 10, right? So, if I put that now all under one radical, I recognize that the square root of 4 is 2. So, that would be 2 square root of 10. So, let's come back to our quadratic formula. This should now be negative 4 plus or minus 2 square root of 10 all over 4. Now, one extra thing that you need to know is if all of your numbers outside of the radical have something in common, then you can reduce that, that equation or that expression. So, 4 and 2 have a 2 in common, so 2 goes into 4 a negative 2 times, 2 goes into 2 a plus or minus 1 time, and then 2 goes into the 4 in the denominator 2 times, and then this would be my final solution. Okay, so I've given you a 0 solution, a positive solution, and now let's try to give you a negative solution. So, if I erase this really quickly, let's try x squared plus 3x minus, equals negative 9. So from this information, am I in standard form? No. Remember, standard form again is ax squared plus bx plus c equals to 0. So I need to move my 9 to the other side. So I add a 9 to both sides, and now I'm listed as x squared plus 3x plus 9 equals to 0. So from this information, I know that a is going to equal to 1, b is going to equal to 3, and c is going to equal to positive 9. So, finding my discriminant, b squared minus 4ac, I would have 3 squared minus 4 times 1 times 9. Well, 3 squared would give me 9, and 9 minus 36 would give me a negative 27. So now that I have a negative number as my discriminant, I know that I'll have no real solutions. So, does that mean that you do not solve for it? No, you still solve for it, but it will just not be a real solution. When you take a square root of a negative number, it just becomes imaginary. So, let's go to one extra step, shall we? So, using my quadratic formula, that'll be negative 3 plus or minus the square root of negative 27 all over 3 times 2 times 1. So, if I break down the negative square root of 27, right, again, I'm saying what multiplies to be 27? Well, that would be 9 and 3, but we're going to leave that as a negative, right? So anytime you take a square root of something that's negative, it is imaginary. So this would be 3i square root of 3. So now I can put this all together in my quadratic formula. This would be negative 3 plus or minus 3i square root of 3 all over 2. And then that is my solution. Again, it's not a real solution because I have this I, which means it's a non-real or not real solution. All right, quiz on this coming soon. Thanks.